Okay. Alright. Assalamualaikum and good morning to all. So today our group one, we're going to present for our group presentation assignment for the case study. So basically on this, we done the case study at one of the members company. So for our group consists of 5 members. So I am Amirul Naufal, and then second we have Khairul Shanizan Yusof, and then third Fitna Raja, fourth Wan Nurul Akmal, and last Hayati. So for this group project, I pass to Khairul first to present on the introduction and the assessment of this group project. Pass to you,
Okay,
Khairul.
thank you, Mr. Nova. I'm Pero. I will present our architecture of a study, our group study, and also the background of the company. So basically, previous slide, please. Okay, basically, we have 4 phase in our study. First is operation background, which is introduction and background of the process flow of the company. Then second one is domain diagnostic. We go to the risk analysis overview, identifying existing practice. And we move to phase 3. It's about risk formalization. It's a hazard analysis and hierarchy. And the final stage is strategic mitigation, which is system implication, hierarchy control, and improvement proposal. Okay, next. So basically, we agree among our team members to conduct a case study at we call it as a company S, a pseudonym for the actual company. So it's located at the Pasir Gudang, Johor. Basically, this company, they produce anti-corrosion fasteners for mostly for the oil and gas industries. Okay, basically, the company is a SME size company. Consists of 4 main four main section in the operation. Firstly is a machining, which is consists of CNC machining, thread rolling, and the second section is cutting, which is cutting the product into the standard order. And also they have 2 sub process, marking and also chamfering. And the third process is washing. We call it washing. The process consists of degreasing, acid pickling, and also the electroplating. Okay, and the third section is a coating, which is to apply the anti-corrosion fluoropolymer coating for the anti-corrosion properties. Okay, next. So here is the process flow for the company. We start from the raw material receiving and go to the machining and cutting process. They cut to length or machining as a per drawing provided by customer. And the second one is sub process is marking and chamfering, still at the cutting and machining section. The marking is product marking is to identify the material grade and also the company identification. Okay. Then potential hazard here we have is heavy lifting. We have a crane, man handling, and also machining. And the second one is you go to the cleaning, which is they have a washing area is to remove the oil and stain, and also to apply the base coat, which is the electroplating layer. Okay, so basically the hazard here we have is a chemical. We have a degreaser, acid, hydrochloric acid, and also the electrolyte of the electroplating process. And at the coating process, they have a chemical. The paint itself is a chemical contained material. And then there is the final process. After coating, they go to the packing for delivery. So there's a basic process flow for the company. Okay. Thank you. I think I pass to the next presenter. Thank you.
Okay, thank you, Khairul. So, based on the process flow just now that Khairul present, actually we go audit this company S and observe the real situation. We assess based on the four dimensional, which is on the safety, health, economy, and environment, and also sustainability. So I will share those some example of the photo that we took from the audit and what is the current existing control and also the risk. For example, this process at the cutting process where we see that the people working near the cutting machine without wearing the PPE. I think highlight in the red circle. This will be risk in term of the any accident. We also see that some hazard in term of the step road on the pallet, which is unstable stacking, will causing maybe some of the accident happen. Let's say the people hit this stacking road. Okay, next. So this is also talking about the safety diagnostic when we see that the hazard in term of the lifting rope from the pallet, which is heavy load, and if let's say something drop object, it cause injury to the people that handle this machine. We also see that manual handling the metal rod, which is a sharp edge, and also using improper glove. So this is also on the risk that we observe. Next, next, okay. So we also do some assessment in term of the ergonomic assessment, where we can see that improper picky rope from the pallet, which is severe bending posture, was observed. And it's also manually a cord grip and hold heavy load. So this is also one of the ergonomic. So repetitive lifting and also sorting, which is can give cumulative shoulder and wrist strain. So for this, one of the critical ergonomic assessment that we assess in this process. Okay, next. For the in term of the environmental comfort diagnostic, we also observe this machining having a risk, heat stress heat, which is a thermal comfort, and also the work place layout also crowded, which is with the pallet and bin, which is can cause the restricted movement and trip hazard. Okay, next. Next, we go to the process for the fluoropolymer coating line, which is we observe also the people that handle the machine are not wearing the proper PPE. Example, for the photo, the people not wearing the glove and also not wearing any proper PPE. Next. And this is a electroplating line. We also observe people to expose to the electric bulb because don't have any cover for the plating line. And we also observe the wiring also is improper. This, if will causing some major incident. Let's say people will go to this line. So danger level here is very danger if fume extraction, and then will cause the fatal risk for the people. So this is all the some example photo that we take. So we will follow the hazard, a high risk for the assessment and further propose preventive action later. Okay. So I pass to the next presenter, sorry.
Okay, thank you Nurul and Khairul for the introduction. So as long as Nurul already present on the assessment and audit to this company S, so we after we audit on the company S, we also together discuss on what is the tools that we are going to use to assess on this risk, and also what is the tools that very suitable for us. And then for the group discussion outcome, all of our members agreed to use HIREC. HIREC is not necessarily is better than all of these FMEA, JSA or risk metric, but HIREC is encompass of all on the risk assessment and together with the risk control. HIREC is stand for the hazard identification, risk assessment and risk control. So on the legal standard also, basically like ISO 45000 for occupational health and safety, and also national legislation globally mandate, HIRA is like the process. If auditor walk in, HIRA is what they want to see. So that's why that's the reason why we are going to use this tool, HIRAC. We are not selecting others not because of others bad or not good, because HIRA is more easy to understand and very straight for our team to assess and to measure the control. So as we can see HIRA here, the scope is a workplace wide and is a comprehensive baseline profiling and establishing risk register. While FMBA is more detailed, it's on the engineering control detail, predicting the mechanical failure points. And then the job safety analysis on the scope is focused on the specific task. If let's say we use job safety analysis, the process of hazard identification and risk control will be quite detailed and more pages to be included. So that's why we use HiRite instead of JSA. And last, we have a tools like risk matrix. Risk matrix is on focusing on specific incident, while our case study here is only on the work activity related to the company as process. So that's why we are going to use HiRac for our case study. So later on, Haryati will present on what are the hazard identification and what are the risk assessment and risk control for all the work activity explained by Nurul earlier on. So I pass to Yati. Thank you.
Okay, thank you. So I will continue with the hierarchy analysis summary dashboard. So this slide summarizes the overall hierarchy assessment conducted for this project. So total of 10 work activities were accessed, resulting in the identification of 56 hazard and risks. So from the risk assessment, 6 risks were classified as a low risk, 50 risks were classified as a medium risk. No high risk activities were identified. This is indicate that all the identified hazard can be managed through the existing control and additional mitigation measure. So looking at the breakdown by work activities, manual transferring of steel recorded 4 low risk and 3 medium risk. Transferring by crane recorded 8 medium risk with no low risk identified. Fluoropolymer coating recorded 1 low risk and 8 medium risk. Electroplating process recorded 1 low risk and 9 medium risk. Machinery and cutting operation recorded the highest numbers of medium risk at 10. So the analysis show that the majority of medium risk are concentrated in the electroplating, machinery and cutting, coating and crane handling activities. So therefore, this area should be prioritized for risk control measure, employee training, supervision and continuous monitoring to reduce the likelihood of incident and improve the workplace safety. So overall, the high risk assessment indicate that no high risks were identified. Proactive risk management is still required to further reduce the number of medium risk and ensure a safer working environment. Next slide, please. Uh, this HIREC form shows the HIREC assessment conducted for the plating process. So the purpose of HIREC is to systematically identify the workplace hazard
assess the associated risks and implement the effective control to prevent injuries and occupational illness. So this is the example. So we have the routine situation with identified work activities. We also do the hazard identification, which is we put what is the hazard, the effect, and the affected parties. We also conducted risk analysis and risk control, which we put the severity, likelihood, and also we identify the risk level. So this is the all the high rank that we assess throughout this project. So from routine, we also conducted emergency situation. So can you scroll down bit low for the emergency? Further down for the emergency. Okay. So this is example for the emergency case. We have the fire outbreak, we have the chemical spillage, we have the power trip, and also medical effect. Okay, so think that's all from my side. I pass to next presenter.
Yeah, thank you, Yati. So I will go through the controls of how we can eliminate all the risks that we identify, and then what are the substitution controls that we can implement. So we can start off with baseline. So the current state that the electroplating uses the hexavalent chromium known as carcinogen, right? So it's a strategic chemical substitution. So for the purpose of this shift is to have some trivalent chromium integration, right? So this kind of change, it will dramatically lower the workforce toxicity levels, also reduce hazardous and waste disposal costs, and ensure compliance with modern OSH regulation, right? At the same time, it will maintain equivalent corrosion resistant performance for the client. Okay, so level 2, we talk about engineering controls. So based on our given situation, so we have two controls that we can place. One is a chemical engineering control and the other one is a biomechanical engineering control. So in terms of chemical controls, so we have implement targeted LEV systems with high velocity extraction hoods and industrial scrubbers at the fluoropolymer station, because that is the station where it involves a lot of chemicals and toxics due to the spraying process. And then for the biomechanical engineering control, we have automated conveyor integration in packing and to do some packing and eliminate manual lifting. So this will help the operators in terms of maintaining a balanced posture or any avoiding any injuries or accident. At the same time, there are installations of interlock guarding with magnetic sensors that stall cutting machines if the shield will open. So the Pokayoki weight sensors for error-proof missing components will also help in this case in terms of biomechanical engineering controls. Okay, so level 3 is administrative controls and PPE. So when we look at administrative controls, so we have implemented a strict standard operating procedures, so which is a SOP, for mandatory chemical safety and visual management tools in the form of safety roadmaps painted directly on the factory floor. So this will provide more awareness and better clarity for the operators who are performing the work in the company S. The next thing we look at in terms of the PPE, which is the personal protective equipment. So the final barrier against the VOC and acids. So we have a spray coating operation which require the PPE. So mandatory use of the disposable chemical protective suits, acid resistant gloves, targeted respirators, and heavy duty safety boots. So all these, in general, are the basic minimum that we need the operators to follow. So this will prevent any injuries or accidents or even fatality. Yeah. Okay, so I will hand over to Naufal to wrap up this presentation.
Okay. Basically, all the presenter from Carol introduction to Vic and the proposal, we can conclude our project case study here, which actually focusing on company S operated as a highly reactive environment with 50 undocumented medium level risk cluster in a chemical and kinetic operation. And then for all of our case study here, and that Vic also mentioned to follow the hierarchy of control based on the pyramid: elimination, substitution, engineering control, amnesty control, and last is a PPE. And then also on the future, we apply the rigorous hierarchy diagnostic and systematically execute this control and follow to the strategy safety engineering, and then last is transform the facility into sustainable, OSS compliant and operational superior industry player. So to conclude our case study on the proposal include together, so the company S will be more suitable and would be the great place to work for all the employee and staff. So that's wrap up on our presentation from Group 1. Thank you. Bye.